All right, now recording. All right, so we did a lot of 4.1 yesterday. I will try to do more 4.1 and hopefully start 4.2. Okay. So that's where we're at. So let's just jump right in. Okay, I was going to show you problem 53. Okay, f of x is x plus 1 over x. Find the absolute maximum and minimum on the closed interval from 0.2 to 4. Okay, and you might recall this is what you want to do. So-called closed interval method. Okay, when you find an absolute max and min of a continuous function on a closed interval. Find the values of f at the critical numbers. So what's a critical number? Derivative is 0 or undefined. Usually it's just 0. Then find the function values of the endpoint. Okay, so out of all those numbers, the highest y value, absolute max. Lowest, absolute min. Right, so that means even before you start, you know right away you have to plug in 0.2 and 4. Okay. All right. So let me take the derivative. Again, if you have 1 over x, best way to treat that is x to the negative 1. Okay, again, if you have a constant either on the top or the bottom, it's best not to do the quotient rule. So like for 1 over x, make it x to the negative 1. So f prime of x is 1 minus x to the negative 2. That's 1 minus 1 over x squared. Set that equal to 0. Clear the fractions by multiplying both sides by x squared. By the way, this is a very common trick. I always do this whenever there's a fraction. I don't like fractions. Clear the fractions, right? Common denominator. Well, the only denominator is x squared. Multiply by x squared, and there's no more fractions, right? X squared minus 1. I like that better, right? X squared times 1. X squared times 1 over x squared is negative 1 equals 0. Factors into x plus 1, x minus 1. That gives me x is negative 1 or positive 1, but negative 1 is not in my domain. They told me only to go from 0.2 to 4. So x equals 1 is here. Okay, let's say this one came out to be 5. That would not be in the domain, so I don't have to consider either one. But x equals 1 is in my interval here. So I will plug in 3 numbers, critical numbers that are in my domain, which is 1. Again, don't plug in negative 1 because it's not in the domain here. And you always have to plug in the 2 endpoints, 0.2 and 4. Okay, so I plug in 0.2, I plug in 4, I plug in 1, the critical number. Okay, and again, to save time, I won't actually punch it in my calculator. I'll just tell you the result. You can punch it in a calculator as good as I can or better. So 0.2 plus 1 over 0.2 comes out to be 5.2. Plug in 1, that's easy. 1 plus 1 over 1, 2. And plug in 4, 4 plus 1/4. I just called it 4 1/4. Okay, so I look at these 3 y values, that one, that one, that one. So which is the highest? That one. Which is the lowest? 2. So absolute maximum is at 0.2, 5.2. Absolute minimum is at 1, 2. And that's all there is to it. Okay. All right, so that's those problems. I'm actually going to go back and do some more critical number problems because some of those were a little bit tougher. Some of you were asking for the hardest. So find the critical numbers of the function. There were some more that were a little bit more difficult. Yeah, over here. So let me show you some of those. Okay, so 37, fractional exponents always bother us. Okay, so find the critical numbers of h of t is t to the 3/4 minus 2t to the 1/4. All right, h prime 3/4 t to the negative 1/4. And then negative 2 times 1/4 is negative 1/2, right? T to the negative 3/4. Okay, rewrite it. We don't want negative exponents. Put that in the denominator, put that in the denominator. So temporarily ignore the green. You have 3/4 t to the 1/4 minus 1/2 t to the 3/4 equals 0. Okay, so I will play the game of simplifying the expression by multiplying by something. But before we go on, t equals 0 is automatically a critical number. 0 is allowed. If you look at the original, I'm allowed to plug in 0, but you're not allowed to plug in 0 here. So t equals 0 is a critical number automatically. Okay, so remember again the definition of critical number on page 280. Critical number, okay, the derivative is either 0 or the derivative does not exist. But the number c that they're talking about is in the domain. Okay, 0 is in the domain, but I can't plug into the derivative. So t equals 0 is a critical number. All right, so now how do I clear the fraction? Common denominator for the numbers is 4, right? 4 would knock out both of these. How do I knock out t to the 1/4 and t to the 3/4 multiplied by t to the 3/4? So multiply both sides by 4t to the 3/4. And of course, if you multiply this side by 4t to the 3/4, it's still 0. 0 times anything is 0. All right, so multiply this by this, the 4's cancel out, right? And t to the 3/4 divided by t to the 1/4, you subtract t to the 2/4, which is t to the 1/2. Minus, okay, how about that times this fraction? The t to the 3/4 drops out completely, and you have 4 divided by 2, which is 2. Okay, so we like that a lot better. Move the 2 over. Remember, t to the 1/2 means square root. So 3 radical t equals 2. Divide by 3. Radical t equals 2/3. Square both sides, t equals 4/9. Okay, so my two critical numbers are 0 and 4/9. 0 because the derivative is undefined, and 4/9 because the derivative would come out to be 0 in that case. Okay, so again, technically for critical numbers, you have to check where it's a derivative 0 and also the derivative does not exist. But yeah, the vast majority of the problems, you don't have to worry too much about the derivative being undefined. Most of the time it'll be defined. Okay, then I should do a couple of trig ones for you. So 41, f of theta is 2 cosine theta plus sine squared of theta. Okay, so find the derivative. F prime, derivative 2 cosine theta is negative 2 sine theta. Remember, derivative cosine is negative sine, right? Then to differentiate sine squared, remember it's parentheses sine of theta squared. So 2 comes down, sine of theta to the first power, then by the chain rule times the derivative of sine theta, which is cosine theta. So I have this. Okay, factor out the common factor of 2 sine theta. There's a 2 sine theta here, 2 sine theta here. So take that out, you get -1 plus cosine theta. All right, so that means sine of theta is 0, or this thing is 0 means cosine of theta is equal to 1. Okay, where is the sine of theta equal to 0? Well, here and here. That means y coordinate is 0, 0, pi, 2 pi, 3 pi, multiples of pi. Cosine of theta is 1. X coordinate is 1. That's here. Well, that's already covered over here. Okay, so theta is k pi, where k is any integer. So these are the critical numbers. Meaning 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and also negative pi, -2 pi, -3 pi, and so on. So all of those, we have an infinite number of critical numbers in this particular case. Okay. All right, and then I was going to show you 43 also. Find critical numbers of x squared e to the -3x. So we have to do the product rule, right? It's been a while since we did the product rule. And by the way, for the next exam, you can put any of the old rules that you want, but of course, if you take up more space for that, you have less room for new stuff. And you say, you know, I don't remember the product rule, quotient rule, chain rule. You can put all those on your next cheat sheet also, but that just means less paper on your, you know, 8.5 by 11 sheet of paper, front and back side. And a reminder, the next exam is not set in stone. I'm not sure I'll finish everything I want in time, but I'll let you know. All right, so product rule. First function times derivative of the second. Derivative of e to the negative 3x is e to the negative 3x times negative 3 by the chain rule, derivative of the exponent. Plus second function, e to the negative 3x times the derivative of the first, derivative of x squared is 2x. Okay, set that equal to 0. And yes, technically you're supposed to set that to be undefined. This expression is never undefined. That's okay for all real numbers. There's no fraction. We're not dividing by 0, no square roots, no logs. So just set that equal to 0. All right, let's take on a common factor. They both have an x. They both have e to the negative 3x. So x, e to the negative 3x, common factor. Okay, take out the x, e to the negative 3x. There's still going to be another x here and a negative 3, right? So negative 3x. Then here, if I take out x, e to the negative 3x, all that I have left is 2. All right, so by the 0 factor property, either this is 0, 0, or e to the negative 3x is equal to 0, but remember that's never possible. Exponential functions can never equal 0. So that's not going to happen. And a little bit of simple algebra there gives me 2/3. So my critical numbers are 0 and 2/3. And again, what's so good about these critical numbers? They're going to give us possible maximum and minimum values, or maxima and minima shortly when we do graphs. Okay, when we get the graphs, say, what's my maxima and minima, maximum and minimum values of this particular graph? Okay. Okay, then the last one I was going to show you for this section was 57. And then I believe I'll be done with section 1. Yeah, then I can start section 2. So 57, a trig one. So this is, again, find the absolute max and min on a given closed interval. So 57, f of t is 2 cosine t plus sine of 2t between 0 and pi over 2. So for sure, for these kind of problems, you're guaranteed to plug in 2 numbers. What 2 numbers do I have to plug in for problem 57? You have to plug in the 2 endpoints, 0 and pi over 2. That's a given. So what else do I plug in? Any critical numbers. Okay. So again, that's where you do this thing. Closed interval method. Okay. So again, it's up to you. Do you want to put that in your next cheat sheet? You can see if I put this whole thing, it takes up a lot of space, right? So it would be worth it, I think, to memorize the algorithm. Okay, for sure, you're plugging in the endpoints and then plug in any critical numbers. So you got a list, right? So from that list, the highest, absolute max, the lowest, absolute min. All right, now in order for me to work with this, I don't want a double angle with a regular angle. So I use the identity from trig. Sine of 2t is 2 sine t cosine t. Remember that from trig? Okay, and again, if you want to put that formula on your cheat sheet you made, it's a double angle formula. You might recall, right? Sine of 2t, 2 sine t cosine t. All right, now for the derivative. Derivative of 2 cosine t is negative 2 sine t. This is a product. So first function, second function. First function times derivative of the second. Derivative of the second is negative sine t. Plus the second function, cosine t, times derivative of the first. Derivative of 2 sine t is 2 cosine t. And set that equal to 0. And set it to be undefined. But again, this trig function that only involves sines and cosines, that's defined for all real numbers. So it's never going to be undefined. Just set it equal to 0. Okay, a little bit of touch up. Negative 2 sine t minus 2 sine squared of t plus 2 cosine squared t equals 0. Okay. Now, in order for me to solve this, I need to get just one trig function. Okay, I don't want a mixture of sine and cosine. Okay, so should I change all the sines to cosine or change the cosines to the sines. And I guess you can sort of think of it as majority rules here. Okay, if I were to change everything to cosine, I have to change both of these, right? If I change everything to sine, I only have to change one. Okay, so the least amount of work is to change this one, right? There's more sines than cosines, so the sines win, so to speak, right? So I'm only going to change the cosine squared. So leave that alone, leave that alone. Okay, so everything up to here is the same. That's the same, that's the same too. And now cosine squared, you might recall cosine squared is 1 minus sine squared of t. Okay, now my equation only says sines. All right, so clean that up. Negative 2 sine t minus 2 sine squared of t, distribute, plus 2 minus 2 sine squared of t equals 0. Clean that up. These two, negative 2, negative 4 sine squared of t minus 2 sine of t plus 2 equals 0. So that looks like a quadratic equation in sine. And how about let me factor out a negative 2 just so I can get the leading coefficient to be positive, right? These are all even, but I usually like positive squared. So take out a negative 2. So it becomes 2 sine squared t plus sine t minus 1 equals 0. Right, so I factor. So 2 sine squared t, 2 sine t and sine t. The only way to get 1 is 1 and 1. Okay, and if you double check a minus and a plus should be to work, you can FOIL it back out. 2 sine squared of t plus 2 sine of t minus 1 sine of t is sine of t and minus 1. Okay, so by the zero factor property, either this is 0, impossible, negative 2 can't equal 0, or this is 0, or this is 0. So what number makes this 0? Sine of t is a half. How about this? Sine of t is negative 1. Right now, we're only allowed to have numbers between 0 and pi over 2, 0 and 90 degrees. So sine of what angle is a half? Pi over 6 for my unit circle, right? Y coordinate is a half. Sine of t is negative 1. That's down here. Well, that's like negative pi over 2 or positive 3 pi over 2. That's not under consideration. So my only critical number within this region is pi over 6. So that means I now plug in 3 values. Pi over 6, the only critical number, and the 2 endpoints. Okay, so I get my list. So I plug in 0, pi over 2, and pi over 6. Right? So f of 0, plug in 0. 2 cosine of 0 plus sine of 0. Sine of 0 is 0. Okay, cosine of 0 is 1. You get 2 plus 0 equals 2. You can plug in 0 right here, 0 right here. That's 0. Cosine of 0 is 1. 2 times 1 is 2. Plug in pi over 2, 90 degrees. Pi over 2 there, I'm taking the sine of pi, which is 0. Put pi over 2 there. Cosine of pi over 2 is also 0. 2 times 0 is 0. So that's going to be 0. And then pi over 6. A little bit harder. Cosine of pi over 6, x coordinate, that's radical 3 over 2. 2 times radical 3 over 2, plus sine of twice the angle. 2 times pi over 6 is pi over 3. Sine of pi over 3 is also radical 3 over 2. So I have 2 radical 3 plus radical 3 over 2. That's 3 radical 3 over 2. You can check it on the calculator. That's actually bigger than 2. This is like 1.7. 1.7 times 3 is 5.1 divided by 2. It's bigger than 2. Okay, so this is like 5.1, 2, and 0. Right, so I'm ready. Absolute minimum, pi over 2 comma 0. Absolute maximum, pi over 6 comma 3 radical 3 over 2. And there we go. Right, and I think I'm done with this section. Okay, let me do my focusing thing again. Raise it up so you can see it better. That. All right, so I think we got that. And let's see, just go back and I'm not sure if I showed you 53 well enough. So there's 53. Okay. All right. So I'm ready to start section 2. So list, I'm marking off 4.1, start 4.2. Okay, the topic is something called the mean value theorem, whatever that is. So we're right on schedule for now. All right, 4.2, mean value theorem. Before we do the mean value theorem, we have to start with something called Rowe's theorem on page 287. Rowe's theorem. Okay, so here it is. You can put this on your cheat sheet or not. Again, if we were meeting face to face, I'd make you memorize it. All right, so Rowe's theorem, page 287. Before you apply Rowe's theorem, there has to be 3 things, 3 hypotheses. Okay, so what are hypotheses? They're like givens. Okay. Remember doing high school geometry proofs, right? And then said, oh, given this and given that, right? So in high school geometry, given, oh, AB equals BC, or angle 2 is congruent to angle 3. Remember doing stuff like that? Those are the givens. So these are the givens, hypotheses. Number 1, F is continuous on a closed interval, AB. F is differentiable on the open interval, AB. So closed interval here, open interval here. F of A equals F of B. That means the 2 endpoints are the same height. Okay. And here are some pictures. Okay. Endpoints are the same height, same height, same height, same height. Okay. Then there is a number C in the open interval from A to B such that F prime of C is equal to 0. Okay. In layman's terms, somewhere the derivative is 0 if all of these are satisfied. Okay. Again, if you want to put on this on your cheat sheet, you may. Okay. If you're going to put this on your cheat sheet, I would abbreviate, like continuous, just put cont, C-O-N-T, differentiable, maybe diff, and don't even write all this other stuff. To save space, maybe I would just write F cont AB, close interval, F diff, open AB, F of A equals F of B. Okay, F of A equals F of B, 2 endpoints are the same height, not like that, same height. Then somewhere between A and B, the derivative is 0. Okay, and here are some pictures. Okay, you could have a constant function, then of course everywhere the derivative is 0. Okay. Here it goes up and then down, differentiable everywhere in between, so somewhere the slope is 0. Here's one that just goes down and up. Somewhere here, they call that C, slope is 0. This picture, there's 2 such C values. It goes up and then down. So here the derivative is 0, here the derivative is 0. So it could happen more than one place, but this theorem guarantees that it happens at least once. Okay, the text goes over a little proof of that. I'm not going to talk about the proof. You're not responsible for the proof. Okay, but that's the idea behind Rowe's theorem. Okay, continuous on a closed interval, differentiable on an open interval. Now, these first 2 are usually pretty easy because the function that they give you is a polynomial, it's a trig function. Okay, almost all nice functions that we know of are continuous and differentiable everywhere on the domains. Okay, so to use the theorem, normally you would just check F of A equals F of B. You have the same height at the 2 endpoints. Okay, then somewhere the derivative is 0. Okay, so how do we use this funny theorem? Okay, so the homework problems weren't that many. It's 1 to 17, and big surprise, I'm going to end up doing most of them anyway. Okay, so what are they talking about? So page 291, 4.2, 1 to 17 odd. And yeah, let me do the picture stuff again for those of you who don't have the book. There's 1. 3 is on the mean value theorem. I haven't told you what that is yet. 5 and 7, Rowe's theorem. 9 is Rowe's theorem. Then after that, you have mean value theorem. I haven't shown you what that is yet. And there's more mean value theorem there. Okay, so I'll at least give you Rowe's theorem today. maybe an introduction to the mean value theorem. All right, number one. The graph of a function is shown. Verify that f satisfies the hypotheses of Rowe's theorem on the interval from 0 to 8. Then estimate the values of c that satisfy the conclusion of Rowe's theorem on an interval. So what are they talking about here? So Rowe's theorem, number 1 and 2, continuous on a closed interval, differentiable on an open interval. Okay. So between 0 and 8, does this thing look continuous everywhere? Can I draw the whole thing without lifting up my pencil and the paper? Yep. Is it differentiable? Yes, it is. Okay, and how do you know? It means you can draw a tangent line everywhere, except maybe at 0 and 8. Okay, but you can draw a tangent, 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 tangent. Okay. Sometimes I think of this, if you like roller coasters again or rides, you know, this is a safe roller coaster, right? There's no kinks. Okay, this is not a safe roller coaster, right? If you got a corner point. Okay, all rides, no matter how they twist you and turn you and upside down and whatever, smooth, right? That's the idea of differentiable. And the third hypothesis given, number 3, f of a equals f of b, same height, 0 and 8. Do we have the same height at 0 and at 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes, same height. Okay. So what can we conclude? Somewhere between 0 and 8, the derivative is 0. Okay, so in this case, they tell us find where that is. Okay, so that shouldn't be too hard. Okay, where does it look like the slope is 0? An obvious place is look for maximum and minimum points, right? So it looks like the slope is 0 right there. So that would be c equals 1. So in your answer, you can put down c equals 1. Sorry, I'm not going to write it. Again, if we were meeting face to face, I'd show you this on the overhead and write on the board, but I can't do that here. And looks like there's also a slope of 0 right here. So where's here? 1, 2, 3, 4, 5 looks like. All right, so put down c equals 1 and c equals 5. All right. That's it for that one. 3 we can't do yet because it involves the mean value theorem. So I'll have to come back to that later. So I'm going to focus on Rowe's theorem right now. So 5 and 7. Verify the function satisfies the 3 hypotheses of Rowe's theorem on a given interval. Then find all numbers c that satisfy the conclusion of Rowe's theorem. Okay, so 5 and 7. So how do you do that stuff? I'll do 5, you do 7. All right, so the function is 2x squared minus 4x plus 5 on the on a closed interval from -1 to 3. All right, do you recall what's the shape of this thing? You don't have to say it or unmute yourself, but just think to yourself. 2x squared minus 4x plus 5, what does that look like? It's a parabola, right? Is a parabola continuous and differentiable everywhere? Sure. And by the way, yes, it opens up because the a is 2. So if it's continuous and differentiable everywhere, it's continuous on the closed interval from -1 to 3. And f is differentiable on the open interval from -1 to 3, which is required by the hypotheses 1 and 2 of Rowe's theorem. Okay, it's a polynomial. Okay, so again, they want continuous on a closed interval, differentiable on open interval. Numbers 1 and 2. 3, f of a equals f of b. So plug in the two endpoints, show they have the same y coordinate, same height. So I plug in -1. 2 times -1 squared is 2. -4 times -1 is 4, plus 5, 11. -1 comma 11. Plug in 3. 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. -4 times 3 is 12. Plus 5, also 11. 3, 11. So yes, hypothesis 3 is satisfied. F of -1 equals F of 3, right? That was number 3 on the list. F of A equals F of B. Conclusion, somewhere between A and B, in this case, -1 and 3, the derivative is equal to 0. Okay, and they just want us to find that. Okay. So let's figure out where that is. Get myself a little organized here. So there is a C between -1 and 3, such that f prime of C is 0. So that's no big deal. So take the derivative, 4x minus 4, set it equal to 0. X equals 1, or in this particular case, C equals 1. Okay, what is C? C is a particular value of X. So don't get confused. It's really the same thing here. C is some particular value of X. So we found such a C. And is this number between -1 and 3? Yes, it is. It's exactly in the middle in this case. It doesn't always have to be exactly in the middle. Okay, I think later we'll see an example where it's not exactly in the middle, but it could be. Okay, then number 9 has something worded a little bit funny. A little bit funny the way they say it. Number 9, let f of x equals 1 minus blah, 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 blah. Show that f of -1 equals f of 1. Okay, that's hypothesis 3, same height. But there is no number C in the open interval from -1 and 1 such that f prime of C equals 0. Why does this not contradict Rowe's theorem? So what did he mean by that? Okay, and yeah, and then all the rest of the problems are mean value theorem. So take care of Rowe's theorem. All right, so f of x is 1 minus x sub 2/3. Plug in -1. -1 to the 2/3. Now, the 2 means what? Square. 3 means cube root. So -1 squared is 1. Cube root of 1 is 1. So 1 minus 1 is 0. Plug in +1. 1 minus 1 to the 2/3. Well, we already know that 1 raised to anything is 1. 1 minus 1 is 0. However, they say there is no number this time C between -1 and 1 such that f prime of C is equal to 0. In other words, the derivative is not equal to 0 anywhere. Let's try it. What's the derivative of this function? -2/3 x at -1/3, which I can write as -2/3 x at 1/3. Set that equal to 0. That cannot equal 0. Okay, when is a fraction equal to 0? Numerator is 0, top is 0, but it can't, it's already -2. So there is no C between A and B, -1 and 1, such that the derivative is 0. And it says, why does it not contradict Rowe's theorem? You can see from here, the function is not differentiable everywhere between -1 and 1. Function is not differentiable at x equals 0. Right, so that violates hypothesis 2 of the Rowe's theorem, right? Okay. So to answer the question, it says, why does it not contradict Rowe's theorem? Because f is not differentiable everywhere between -1 and 1, right? It's not differentiable at 0. Right, so that's Rowe's theorem. Let me see how much time I have left. I will introduce the mean value theorem. I'll save the actual homework problems for tomorrow, and then hopefully I'll give you something to do in class, provided that I don't pull the plug like I did yesterday, but we'll see how it goes. Okay, so introduction to the mean value theorem. It's a little bit harder. Again, you can put it on your cheat sheet. Mean value theorem on page 288. Number 1, f is continuous on a closed interval from A to B. 2, f is differentiable on an open interval from A to B. That sounds like number 1 and 2 for Rowe's theorem. In fact, it is. It's exactly the same thing. So for something called the mean value theorem, 1 and 2 are the same, but there's no 3. Notice there's no 3. Which means these two endpoints don't have to be the same height. It can be like that or like that, but still continuous and differentiable. Continuous on a closed interval, differentiable on an open interval. What is our conclusion? Unfortunately, it's not as nice. Okay, f prime of c equals f of b minus f of a divided by b minus a. This is also true, but you don't really want to look at that. Okay, so I would say don't put this part on your cheat sheet. It's true, there's nothing wrong with it. But how do you go from here to here? Just multiply both sides by b minus a, and it looks like that. So I don't think it's necessary. Basically, this says somewhere the slope of the curve equals the slope of this line segment joining the two endpoints. That looks like y2 minus y1 divided by x2 minus x1. So this time the slope isn't 0, maybe it's 3. Suppose this came out to be 3. Then we're saying somewhere the slope is 3. Suppose this came out to be negative a half. We're saying somewhere the slope is negative a half. Okay. And I'll show you the picture. Figure 3. Here's a function. Looks like it's continuous between A and B, differential between A and B, but notice it's not the same height. So you have a slope, y2 minus y1 divided by x2 minus x1, which is what this thing is. F of b minus f of a divided by b minus a. F of b minus f of a divided by b minus a. That's y2 minus y1 equals x2 minus x1. That's the slope of the line joining the two endpoints. Okay. Now, in Rowe's theorem, that slope was 0. The slope joining two endpoints. When we say they're the same height, we're basically saying the slope is 0. Okay, so somewhere between A and B, slope is 0. In this case, they're not the same height. So just eyeballing this, the slope looks like, okay, does that look like a positive or a negative slope? Negative, right? Let me just make up something, negative a half. Mean value theorem says somewhere the slope is negative a half. Right? There's the picture. In this case, look at the graph, continuous differentiable, not the same height. This slope looks positive, right? I don't know, how about I'll make it up, 1/4. Somewhere between A and B, slope is a 4th. And just showing you the two such pictures. Okay. What's really happening is the mean value theorem is Rowe's theorem tilted, so to speak. If I kind of tilt the book like that, and if you can kind of ignore all the words that are there, if you can kind of hide all this and just look at that and say, oh yeah, that looks like Rowe's theorem. Right? And say, oh yeah, slope is 0. So this red line, slope is 0, right? It's basically Rowe's theorem tilted. Same thing for figure 4. Okay. Now, you know, if I go like this, the book is tilted, but if you can ignore that, temporarily ignore all the words. Okay. If I can kind of just blot this out and don't look at the graph, and I can't really do it, but pretend I cover that up, cover all the words, only focus just on that. Say, oh yeah, there's Rowe's theorem. A and B are the same height. So somewhere the slope is 0. So those two red lines have a quote unquote slope of 0. So the mean value theorem is really just Rowe's theorem tilted on its side. Okay. Again, so for mean value theorem, only 1 and 2. Rowe's theorem, you had 1, 2, and 3, right? Number 3, the two endpoints were the same height. Mean value theorem, two endpoints are not the same height necessarily. Okay, that means the slope is non-zero. It's going to be either positive or negative. Okay, so here's the slope of the line joining those two endpoints. Somewhere between A and B, you attain that slope. That's what it's saying. F prime of C is equal to F of B minus F of A divided by B minus A. So if this slope here, okay, it's not 0, right? If they were the same height, Rowe's theorem, slope is 0, right? Slope is 0, slope is 0, slope is 0, slope is 0. That means somewhere between the two, the derivative is 0. Here, slope is not 0. I don't know, negative a third. Somewhere the slope is negative a third. Here the slope is 1/4. Somewhere the slope is 1/4. That's what the mean value theorem says. Okay. All right, the rest of the problems in this section, and I'm just about done. I did all the Rowe's theorem problems that I wanted to do, which was basically everything except one problem, I think. So number 3, mean value theorem, I'll save that for tomorrow. So the only Rowe's theorem you have to do on your own, I guess, is 7. Okay, and then after that, 11, 13, 15, 17 are mean value theorems. So I'll save that for tomorrow. Okay, all right, but I was going to stop right now and let you try one problem in class. Okay, so for right now, you can just type the answer in the chat. Go back to 4.1, give you one problem that I hope is fairly easy. So the remaining time, find the critical numbers of the function. Okay, why don't we just try 31 right now? Okay, 31. Yes, it's an odd problem. Yes, the answer is in the back of the book. So if you're super, super lazy, just turn to the back of the book, type in the answer. I won't know the difference, but of course, you're not really learning anything. All right. So right now, just do 31. If you have your book, just look at 31. If you don't have your book, take a picture right now on your cell phone or do a screenshot. I'll hold it up for maybe another 15 seconds. Okay, critical numbers, what does it mean? Take the derivative, set it equal to 0. Okay, so find the derivative, that should be the hard. Set it equal to 0. Looks like you have to do some factoring. And then my critical numbers are blah, 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 blah. Type it in the chat and I'll see you tomorrow. Okay, so 31, 2x cubed minus 3x squared minus 36x. Okay, take the derivative, set it equal to 0, solve. I can go ahead and tell you there should be 2. I think there's 2 anyway. But worst comes worst, you can check the answer in the back of the book. Okay, when you type it in the chat, then you may leave. Okay, all right, I will assume that everybody has it now. There's really no reason why anybody shouldn't, unless you're not paying attention. And obviously I can't tell, since most of you can't see, unlike meeting face to face. Okay, so just 31, give me the critical numbers. If you really want to cheat, you can just type the answer in the back of the book, but that doesn't help you for learning. And that's it. Okay, so I'll stop the share. That should be enough time. And start typing in the chat and you may leave, and I'll stop recording.